The hull is the watertight body of a shipboat. Above the hull is the superstructure and/or deckhouse, where present. The line where the hull meets the water surface is called the waterline. The structure of the hull varies depending on the vessel type. In a typical modern steel ship, the structure consists of watertight and non-tight decks, major transverse and watertight members called bulkheads, intermediate members such as girders, stringers and webs, and minor members called ordinary transverse frames, or longitudinals. Depending on the structural arrangement, the uppermost continuous deck may be called the upper deck, weather deck, spar deck, main deck, or simply deck. The particular name given depends on the context, the type of ship, boat, the arrangement, or even where it sails. Not all hulls are decked. In a typical wooden sailboat, the hull is constructed of wooden planking, supported by transverse frames and bulkheads, which are further tied together by longitudinal string as a ceiling. Often but not always there is a centerline longitudinal member called a keel. In fiberglass or composite hulls, the structure may resemble wooden or steel vessels to some extent, or be of a monocoque arrangement. In many cases, composite hulls are built by sandwiching thin fiber-reinforced skins over a lightweight but reasonably rigid core of foam, balsa wood, impregnated paper, honeycomb or other material. General features. The shape of the hull is entirely dependent upon the needs of the design. Shapes range from a nearly perfect box in the case of scow barges, to a needle-sharp surface of revolution in the case of a racing multi-hull sailboat. The shape is chosen to strike a balance between cost, hydrostatic considerations, hydrodynamics and special considerations for the ship's role, such as the rounded bow of an icebreaker or the flat bottom of a landing craft. Hull shapes. Hulls come in many varieties and can have composite shape, but are grouped primarily as follows: chined and hard-chined. Examples of the flat-bottom, V-bottom and multi-bottom hull have at least one pronounced knuckle throughout all or most of the length, molded, round bilged or soft-chined. Examples of the round bilge, semi-round bilge and S-bottom hull. Defined as smooth curves. Categorization. After this they can be categorized as displacement. The hull is supported exclusively or predominantly by buoyancy. Vessels that have this type of hull travel through the water at a limited rate which is defined by the waterline length. They are often heavier than planing types, though not always. Planing. The planing hull form is configured to develop positive dynamic pressure so that its draft decreases with increasing speed. The dynamic lift reduces the wetted surface and therefore also the drag. They are sometimes flat-bottomed, sometimes V-bottomed and more rarely round-bilged. The most common form is to have at least one chine, which makes for more efficient planing and can throw spray down. Planing hulls are more efficient at higher speeds, although they still require more energy to achieve these speeds. An effective planing hull must be as light as possible with flat surfaces that are consistent with good sea keeping. Sailboats that plane must also sail efficiently in displacement mode in light winds. Hull speed. Semi-displacement, or semi-planing. The hull form is capable of developing a moderate amount of dynamic lift. However, most of the vessel's weight is still supported through buoyancy. Most used hull forms at present. The most widely used form is the round bilge hull. The inverted bell shape of the hull, with smaller payload. The waterline cross-section is less, hence the resistance is less and the speed is higher. With higher payload, the outward bend provides smoother performance in waves. As such, the inverted bell shape is a popular form used with planing hulls. Hull forms: chined and hard-chined hulls. A chined hull consists of straight, smooth, tall, long, or short plates. Timbers are sheets of ply, which are set at an angle to each other when viewed in transverse section. The traditional chined hull is a simple hull shape because it works with only straight planks bent into a curve. These boards are often bent lengthwise. Plywood chined boats made of 8 feet by 4 feet sheets have most bend along the long axis of the sheet. Only thin ply 3 to 6 mm can easily be shaped into a compound bend. Most homemade constructed boats are chined hull boats. Mass-produced chined power boats are usually made of sprayed chopped strand fiberglass over a wooden mold. The Cajun pirogue is an example of a craft with hard chines. Benefits of this type of boating activity is the low production cost and the fairly flat bottom, making the boat faster at planing. Sailboats with chined hull make use of a daggerboard keel. Chined hulls can be divided up into 3 shapes: flat-bottom chined hulls, multi-chined hulls, V-bottom chined hulls, sometimes called hard-chined. Each of these chined hulls has its own unique characteristics in use. The flat-bottom hull has high initial stability but high drag. To counter the high drag, hull forms are narrow and sometimes severely tapered at bow and stern. This leads to poor stability when heeled in a sailboat. This is often countered by using heavy interior ballast on sailing versions. They are best suited to sheltered inshore waters. Early racing powerboats were fine, forward and flat aft. This produced maximum lift and a smooth, fast ride in flat water, but this hull form is easily unsettled in waves. The multi-chine hull approximates a curved hull form. It has less drag than a flat-bottom boat. Multi-chines are more complex to build but produce a more seaworthy hull form. They are usually displacement hulls. V or arc-bottom chine boats have a V shape between 6 and 23 degrees. This is called the dead rise angle. The flatter shape of a 6 degrees hull will plane with less wind or a lower horsepower engine but will pound more in waves. The deep V form is only suited to high-power planing boats. They require more powerful engines to lift the boat onto the plane but give a faster, smoother ride in waves. Displacement chined hulls have more wetted surface area, hence more drag, than an equivalent round hull form for any given displacement. Smooth curve hulls. Smooth curve hulls are hulls which use, just like the curved hulls, a sword or an attached keel. Semi-round bilge hulls are somewhat less round. The advantage of the semi-round is that it is a nice middle between the S-bottom and chined hull. Typical examples of a semi-round bilge hull can be found in the Centaur and laser cruising dinghies. S-bottom hulls are hulls shaped like an S. In the S-bottom, the hull runs smooth to the keel, as there are no sharp corners in the fuselage. Boats with this hull have a fixed keel, or a keel midsword. This is a short fixed keel with a swing keel inside. Examples of cruising dinghies that use this S-shape are the Ingling and Randmere. Appendages. Control devices such as a rudder, trim tabs or stabilizing fins may be fitted. A keel may be fitted on a hull to increase the transverse stability, directional stability, or to create lift. A protrusion below the waterline forward is called the bulbous bow and is fitted on some hulls to reduce the wave-making resistance drag and thus increase fuel efficiency. Bulbs fitted at the stern are less common but accomplish a similar task. Terms. Baseline is an imaginary reference line used to measure vertical distances from. Bow is the front part of the hull. Amidships is the middle portion of the vessel in the fore and aft direction. Port is the left side of the vessel when facing the bow. Starboard is the right side of the vessel when facing the bow. Stern is the rear part of the hull. Waterline is an imaginary line circumscribing the hull that matches the surface of the water when the hull is not moving. History. Rafts have a hull of sorts. However, hulls of the earliest design are thought to have each consisted of a hollowed-out tree bowl. In effect, the first canoe's hull form then proceeded to the coracle shape and on to more sophisticated forms as the science of naval architecture advanced.